Berlin, Germany. A construction team races to finish the largest train station in Europe before next summer's World Cup comes to town. To meet this deadline, 2 massive steel towers must be tipped over their new glass station in under 3 days. It's an engineering feat never before attempted. Can this team of engineers get this daring plan to work? In Germany, builders are racing to complete an architectural crown jewel. They've labored for over a decade, confronting one disaster after another. When finished, this will be the largest train station in Europe. 7 levels containing a staggering 180,000 square meters of space. Nearly as much space as the Empire State Building. Even more amazing, 2 office buildings will straddle the station, both standing 14 stories tall, with 4-story high bridges suspended just above the glass and steel roof of the station. The price tag? Over 4 billion euros and counting. Financed by the Deutsche Bahn, the German rail company and the government, and designed by a world-famous architect, the project is intended as a bold statement. If it works, it will literally and figuratively reconnect East and West Germany, ushering in a new era of unification. But the project has faced terrible setbacks. It's years behind schedule and billions over budget. To make matters worse, the architect is suing the developers for cutting corners on his design. Soon, the project will be coming to a head. The builders are about to execute a move never before attempted in the history of construction. They will attempt to gently pivot these 2 massive halves into their final position, forming a steel bridge just 2 meters above the station roof. It's a terribly risky scheme. If anything goes wrong and the bridge sections hit the glass roof below, the project would suffer unthinkable damage, and the cost would go up by more millions. Will Berlin's new central railway station ever be finished? Since the 1989 fall of the Berlin Wall, Germany's capital city has undergone a frenzy of rebuilding in an attempt to reclaim its historical place as the cultural and economic center of Europe. What better way to solidify that role, planners thought, than with a truly world-class rail station? As the centerpiece of a completely rebuilt transportation system, the station would not only relink East and West Germany, but all of Europe, by connecting Paris with Moscow and Stockholm with Vienna. Berlin, of course, would be at the center of it all. But today, 5 years after its original scheduled completion date, the project is still under construction. And it's reached a critical moment. Down on the streets, crowds begin to form. They've come to watch an unfolding drama. A milestone event in the history of construction engineering. The fate of the entire project hinges on this step. Up in the air, a team of specialized engineers and workers are preparing to execute a dangerous maneuver. Scaling the steel like mountain climbers, workers make their final adjustments. Check and double-check hundreds of details. All eyes are now focused on a pair of huge steel bridge sections. When finished, they will form a bridge, 4 stories high, hovering just above the roof of the train station. The bridge will join the 2 sides of the office building and will itself contain thousands of meters of office space. Because building a working train station was the top priority for builders, the twin office towers would have to be built after trains were running through the nearly completed station. One of their original ideas called for building the bridge the usual way, starting at one side and building out horizontally over to the other. But engineers realized that building the bridges that way was too dangerous. Safety officials lay awake at night at the thought of cranes swinging these huge steel girders above their new glass-roof train station, packed with thousands of commuters. They'd be forced to shut down train services over 6 weeks until the bridge was done. But that would have brought Berlin to a standstill. So engineers came up with a remarkable solution. They would build the bridge in halves. Each half was built not out, but up. Now the 2 halves are ready to be lowered into place with cables. The tipping technique has never before been used in an urban setting. But now, there's no turning back. Starting at 10 tonight, train services through the station will be halted. But only for the weekend. They'll have 54 short hours to get the bridge lowered and the sections attached. But each section weighs over 1,200 tons. If something goes horribly wrong, it could mean the total destruction of the station's spectacular new glass roof. It has one of the largest glass roofs in Europe. Over 11,800 individual square panes. Each pane weighs almost 100 kilograms, bringing the total weight of the glass alone to 1.2 million kilograms. That's a lot of glass. World-famous architect Meinhard von Gerken knew from the beginning that he wanted glass to play a prominent role in the station's design.
The most important thing for a public building is to have the impression of daylight. You feel much better if you are part of the total environment, the natural environment.
As it happens, big glass structures are all the rage in Germany right now. When the Reichstag, the German parliament, was rebuilt in 1995, the government insisted on installing a glass dome on top to reflect the new German transparency. Glass has traditionally been a material of choice for train station designers, but it's always been expensive and tough to work with. Early train stations with glass also needed immense support structures of steel to hold up all that heavy glass. The result, in spite of the glass, not much natural light could get in. The stations were still pretty dark. Von Gerken wanted to do better. His design called for a massive curving glass tube, 16 meters high, 60 meters wide, and over 400 meters long, to form a nearly transparent roof and walls for the main platform. He needed to find a way to eliminate all that steel, to have the glass support itself, or at least appear that way. But a glass structure can be as dangerous as it is beautiful. In 2004, almost a year after its opening ceremony, a brand new glass terminal at Paris's de Gaulle airport suddenly collapsed, killing 4 people. Investigators pointed to both design flaws and construction defects. Now, with just hours to go before the crew here in Berlin attempt one of the most unorthodox construction tricks in history, the possibility of disaster cannot be far from anyone's mind. It is the ultimate challenge for a project that has missed one deadline after another. Today, a new deadline looms, and the teams know they can't blow it. Mid-next year, the World Cup football tournament will focus the world's attention on Germany, the most watched sporting event in the world with an audience of billions, more than even the Olympics. Millions of fans from across the globe will flood into Germany, with the final game here at Berlin's Olympic Stadium. City officials desperately want the global event to also serve as the station's inauguration. Berlin officials expect up to 3 million football fans to descend on the city. They desperately need the station completed, because once the games begin, nearly 500,000 fans will use it every day. If the project is still under construction, it will be a huge embarrassment for the country in front of an international audience. All this pressure now sits squarely on the shoulders of the two men in charge of the operation. Olaf Severin will run the crew lowering the South Tower. Bernd Naujoks will lead the North Tower team. They go over the plans one last time. Years of preparation have led up to this weekend. At 10 tonight, all train traffic through the station will be halted. Olaf and Bernd must complete the work by 4 a.m. Monday, the start of rush hour, when the train schedule must resume. If they're late, Berlin becomes one huge traffic jam. Between now and Monday, neither one of them plans to get much sleep. On paper, the plan is simple. Each bridge section currently stands on its end. Both towers are fitted with 12 massive jacks, 4 on top and 8 on the bottom. To begin tipping the sections, the men will first activate the top jacks. These jacks pull up on a series of steel cables anchored to the tower, tipping the tower on a single pivoting hinge. Once it reaches an angle of 15 degrees, it will start to fall. To keep it from crashing down, the bottom jacks are now activated. These jacks act as a brake, lowering the tower by slowly letting out a second set of cables, centimetre by centimetre. The two sets of jacks share the load until the bridge sections reach an angle of about 40 degrees. At that point, the bottom jacks take over completely for the rest of the ride. A simple plan, but with years of experience, Olaf knows problems could spring from any direction. Snapped cables, misfiring hydraulics, high winds. So computers are on board to control the process. They can monitor the shifting weight, regulate the speed of the jacks, and shut down everything if they sense a problem. Olaf and Bernd share final authority, and each of them knows that if they have to, they can override the computers. The two decide to make a bet on who will get to the bottom first.
One thing's for sure, Bernd. We will reach the bottom first.
What? No.
Let's bet a case of beer.
But before the starting horn can sound, final safety measures must be finished. Workers dangling 70 meters in the air attach nets to the bottoms of the bridge sections. The nets are supposed to protect the nearly 12,000 glass panels of the station roof, in the event that something falls from one of the sections during the tilt. Glass has been used in train station roof construction for over a century. But early builders were limited by the expense and fragility of glass. So builders kept both the size and the quantity of the panes they used small. Architect von Gerken's design for the new Berlin station called for nearly 12,000 panels, each over a metre square. For such a vast quantity, project managers came here to the Guardian Flock Glass factory just outside Berlin. Virtually all of the glass used in the station was manufactured here, using a modern method called the float process. Today's high-quality glass is made from a blend of raw materials, including silica, soda, and lime. These ingredients are combined with recycled glass and fed into a huge furnace. The furnace is heated to over 1500 degrees Celsius, hotter than volcanic lava. So hot, workers can only keep watch through tiny windows, wearing heat-resistant clothes and goggles. The extreme heat inside the furnace melts the ingredients into a liquid glass. The glass spreads out over a layer of molten tin. Because the plane of contact between the two liquids is perfectly flat, the resulting glass will be virtually free of optical distortion. Next, the glass is slowly cooled in these 120-meter-long giant coolers. This factory could theoretically produce glass sheets over a kilometer long, but they would be essentially impossible to ship. So each piece is then scored, cut to size, and trimmed. But the glass panels von Gerken needed for the train station needed to not only be large, but also extra strong, capable of withstanding bad weather and the constant vibrations from trains. So the glass for the station is tempered to make it twice as strong as normal window glass. As a final step, a layer of UV-absorbing material is fused with the glass. This step helps prevent the station from becoming the world's largest hothouse. Back at the construction site, there are only 3 hours left until the big tip-over is supposed to begin. Team leaders Olaf and Bernd are anxiously awaiting the signal that train traffic through the station has been halted so that they can begin the delicate operation. But now there's a new worry. The skies over Berlin are looking ominous, and severe thunderstorms are forecast. The two men know they must do everything they can to stay on schedule. The trains can only be stopped for 54 hours. But they can't put their men at unnecessary risk. If the conditions get too bad, they'll be forced to call off the procedure. As night falls, there's nothing to do but wait and hope that the storm blows over. (10 p.m. at the construction site of the massive Berlin rail station, and lightning is lighting up the sky all round. Rain is coming down in sheets, but the wind seems to be holding, so engineers make the difficult decision to proceed.
Lightning should not be a problem. The wind has starting to increase, but our static calculations consider such wind loads.
After the last train leaves the station, the starting horn blares. Foreman Bernd gives the signal, and his North Tower team springs to action. The name of the game in this entire process is control. The computers, jacks and cables must keep the massive weight of the bridge sections under constant and complete control for the entire tilt. If they don't, the sections could jerk or start to sway, which could be disastrous. Of course, gravity will be doing most of the work. All the machinery and all the men are here simply to keep gravity from working too fast. The scariest point will be the moment when the center of gravity shifts on the bridge sections. At that moment, the 12 jacks and nearly 400 cables will be pushed to their limit as they carefully lower the 1,250-ton weight of each section over the station. If the team can get past that changeover point smoothly, the rest of the ride down should be easy. The operation is the first time in construction history that two massive towers have been intentionally tipped over so much glass. It's taken months to place the thousands of glass panels. Each panel sits inside a perfectly sized steel square frame. This interlocking steel framing matrix is a crucial element of the design because the steel itself is so thin it almost looks like the glass is supporting itself. Architect von Gerken wanted the station flooded with light, so he needed to find a way to hold up the glass with as unobtrusive a support structure as possible. And he could not sacrifice safety. The structure needed to hold firm against constant vibration from the trains rumbling through below. Hundreds every day. Von Gerken also wanted to avoid cluttering up the interior of the station with traditional support posts. So project engineers came up with an ingenious solution. An elaborate skeleton of external supports. This steel anchor joint weighs 4 tons, nearly as much as 2 SUVs. It's one of 46 identical anchors that, when placed and bolted, will serve as the primary support for the entire glass and steel lattice above. Each joint will be capable of holding almost 200 tons. Placement is critical. A surveyor carefully guides the team. Once the anchor joint is secure, cranes lower one end of an 11-ton end section of one of the station's arching main support beams. It's not unlike the world's biggest door hinge. First, the crew carefully aligns the holes. Then a 300-kilogram steel locking pin is slid through the holes. This hinged joint will let the huge beam sections rotate as needed during construction. They will also let the entire structure expand and contract without creating wear and tear on the joints. Once this end of the beam is locked into its anchor, the other end can be placed into an identical facing anchor on the other side of the station. Each complete beam is made up of 4 interlocking sections. The steel and glass latticework hang between these mammoth support beams. After the last beams of the steel support arches are placed and welded, it's time to install the glass. Cranes specially fitted with suction cups gently lift one pane at a time to the crew. This part of the job requires calm hands, a steady nerve, and a delicate touch. Working 16 meters above the tracks, workers must stretch to receive the glass. and then stretch again while they dangle over the open steel frames. A spritz of glue, and the pane pops in. It took the crew working day and night for 4 months to install the glass to this point. Today, only a 9 square meter section remains to be glassed. And while it's been all sorts of fun, nobody here relishes the thought of having to repeat this process. And that's just what they'd have to do if this station roof winds up getting smashed to bits by an out-of-control bridge section. Back at the tip-over, workers wait for the signal to start. Bernd calls from the control room. They flip the switch. The huge jacks spring to life, and the massive towers begin their slow descent, 6 meters an hour. As rain pelts the station, and all train traffic through the station remains stopped, workers check and recheck the tower's progress. Since the movement is almost imperceptibly slow, a simple ruler and bubble level provide assurance that the huge sections are indeed moving at all. Bernd's North Tower takes a slight lead. One of their main concerns, the cables. If a cable binds or gets stuck for any reason while going through the jacks, it could cause the steel to jerk and sway. So workers armed with lubricant will keep that cable well oiled all night. Their crazy plan seems to be working. Then suddenly, less than 2 hours into tilting, a problem erupts for Bernd's North team. The electronic signal coming from one of the jacks suddenly stops working. Without a signal, the emergency system kicks in. Tipping on the North Tower is automatically halted. Now it's a race against the clock and the weather. Three hours ago, tip-over came to a sudden halt when communication between one of the jacks and the control room was lost. When working, the signal allows the computers to control the tower's every movement. Technicians believe the heavy rain shorted the line. It could take hours to fix. Back in the office, team leader Bernd Naujoks makes a bold decision. With so much on the line and the clock ticking, he decides they can't wait for repairs. He tells his team to fire up the jacks once again. Without the precise monitoring of the computers, engineers must monitor every centimeter of the tip-over, manually, with surveying tools and levels. One more job for an already overtaxed crew. Even the slightest miscalculation could spell disaster, but it's a risk Bernd feels he must take. Just another crisis for a construction project that has been plagued with problems. From the beginning, one of their biggest problems was the location. To most people, these scenes are reminiscent of Venice. But this is Berlin. The city is built around 2 main rivers and countless smaller waterways. The water adds charm to Berlin, but it adds all sorts of complications to builders' plans. When you build a billion-euro mega train station, it's all about location, location, location. The chosen location for the new station had once been the site of a majestic train station called the Lehrter Bahnhof. But that station suffered irreparable bomb damage during World War II and was then demolished in 1959. In the early 1990s, when planners first came here, only a small local train terminal stood on the grounds. The land for the new station was vast and centrally located, right in the middle of Berlin. The perfect spot. But big problems popped out at engineers immediately. The ground beneath the site, along the bank of the Spree River, was mainly composed of fine sand. While the site was adequate for this small terminal, the new station would be several times larger. Nothing that large could ever be built on top of this sandy site, and that wasn't the only problem. The ground was also extremely saturated with water, making the construction area even less stable. Engineers needed to not only build a solid foundation, the size of 11 football fields, across this sandy area, but also construct the 2 lower floors of the station below the groundwater level. In 1996, construction began on the 90,000 square meter foundation and the lower station floors. To do this, workers first boxed in the massive area with waterproof walls. The 1.5 meter thick concrete walls extended down 25 meters below the surface. Excavators then shoveled out the earth between the walls. As they removed the dirt, the groundwater filled in. Once they excavated to a depth of 20 meters, they poured a 1.5 meter thick concrete floor under the water. Divers then reinforced the concrete corners, making a watertight box. The water left in the box was pumped out, but without the water in the box to equalize the pressure, the water below these concrete floors would exert a tremendous force on the new foundation, 20 tons per square meter. This pressure would cause the floors to pop like a champagne cork. To prevent this, the floor was held down by a series of long steel piles, almost 30 meters long. With these huge spikes holding the foundation firmly in place, the rest of the station could be built. Bridges and support beams could be erected, and tracks laid into position. But a big question still remained. Would it hold up the trains? Engineers had to be certain their glass-domed station sitting on a bed of water and sand could hold up under constant pounding. A train weighs about 800 tons, or as much as 300 pickup trucks, running over the bridges and supports over 50 times an hour. So the station was put through a rigorous battery of tests. Motion sensors were attached in key areas throughout the station, on the bridges, the supports, and along the tracks. Then they called in the big rigs. Trains weighed down with over 40 tons of concrete slabs, running over the tracks, over and over and over again. Measurements were taken all along the track and fed into a master computer. The station was designed to be flexible, but if it shifted by more than 5 millimeters, they would need to shut down until it could be reinforced. When the final readings were measured, the station held up. It was ready for trains. In July 2002, the media came out in force to watch the first train to ever run through here. But no one was calling this station done. Today, the pressure to get it done sits on foreman Bernd Naujoks. Since he made the daring decision to restart the tipping of the North Tower, without the computer signal from the jacks, his tower is once again slowly lurching forward, tipping 6 meters an hour. Bernd's big gamble seems to be paying off. He only hopes it stays that way. It's been a long, sleepless night for workers attempting to tip 2 megatowers at Berlin Central Station. And no one is sleeping now. Foreman Olaf Severin's South Tower is about to reach the scariest stage of tip-over, when it reaches a 30-degree angle. At that moment, the center of gravity starts to shift on the bridge sections, slowly switching the burden of the tower's weight, all 1.3 million kilograms, over from the upper jacks to the lower jacks and cables. The jacks must maintain equal tension on either side of the tower. The delicate balancing act continues until about 40 degrees, when the upper jacks will no longer be assisting the tip over. If it isn't executed perfectly, this tower could start to swing out of control. As the South Tower reaches the critical angle, a team of surveyors starts computing some of the most important data of their lives. Bleary-eyed from lack of sleep, they work quickly, checking their predicted calculations against what they're actually seeing. After checking everything, the tower's angles are all within the acceptable range. They believe the lower jacks and cables are ready to hold the entire tower. Olaf stops the tipping. Over 1,200 tons of steel and concrete dangle above, held in place by nearly 400 steel cables. The 4 upper jacks are no longer needed. So 3 workers crawl up to take them apart and remove their cables. Now just the bottom jacks remain to lower the massive tower, weighing more than 6 jumbo jets. The starting command is given. Pumps hiss, jacks groan. 250 steel cables strain from holding up all that weight. The surveyors and engineers keep vigilant watch. But the cables hold. It should be all downhill from here. Down on the street, a crowd has formed to watch the show. This guy thinks they're doing it all wrong.
On this side, the ropes are slightly loose. I don't know if everything's been thought through.
12 stories above, the North Tower just passed through the critical switchover stage unscathed. Since making the daring decision to tip without computer monitoring, Bernd's team has managed to make up some lost time. If they keep at this pace, they'll finish ahead of their deadline, but still behind the South Tower.
I have to get going and buy the beer. I'm afraid I'm having difficulties catching up with Olaf.
But they'll need to settle their bet later. because they're about to reach the final tip-over stage, when the two towers are brought together, forming a steel bridge. Like giant puzzle pieces, the North Tower was built to mount into the South Tower. For that to happen, both 44-meter-long towers must come together at exactly 83 degrees and then be lowered simultaneously before finally landing only 10 centimeters apart. They are ready for the final stage. With precious time already lost, the two teams get right to work. Bernd climbs over unfinished beams, more than 40 meters out to the edge of his tower. From this precarious position, he can coordinate the movements between the towers. He gives the signal, and the towers are on their way down, only 5 millimeters at a time. A little up, a little bit over, a little down. Bernd checks to see if they're level. Voila! The lowering is now complete. Exactly as planned, only a 10-centimeter gap remains between the towers. To pull them together, hydraulic pumps, each pulling 100 tons, tow the two sides in tight, forming a bridge unifying north with south. But now is not the time to admire their handiwork. Before Berlin's trains can run through this station safely, there is still a lot of work to do. Workers must bolt the bridge sections together, make hundreds of welds, and lay over 1,500 square meters of flooring. Hours behind schedule, they know all this work will take them right down to the wire. With the tipping stage complete, the foremen finally find a moment to relax. Bernd's not empty-handed.
Super job.
He knows when he's been beaten. But not everyone is celebrating, especially the architect. In 2002, already years behind schedule, the Deutsche Bahn, the German rail company that owns the station, decided to take drastic measures to meet their World Cup deadline. They decided to alter some features of the design. Over the architect's objections, they made two major changes. The first was to the station's most noticeable feature, the glass roof. Von Gerken's design had a 430-meter-long roof, long enough to cover the longest trains. The glass and supports were manufactured to cover the entire length. But before they were installed, the glass canopy was shortened, ending it 100 meters short. But perhaps the biggest change is in the lower subway terminal, where light cascading down from the upper levels was supposed to reflect off a massive cathedral ceiling made of metal, casting natural light 5 stories beneath the ground. Instead, the great cathedral was covered with a drop ceiling.
Like in a supermarket. Without any details, without any expression, without any charisma.
The changes have saved the project time and money.
That's how it is in big projects. You have to decide, do I want to meet my requirements, my time schedule, or do I want to finish every small piece of it?
But for the visionary architect von Gerken, there are no small pieces of his masterpiece.
I must say it was the biggest loss I ever had in my professional work. I, as architect, have built so many buildings, more than 200. Nowhere have things happened like this.
Von Gerken is so outraged he has now brought the case to court, hoping his vision may one day be realized, even if it has to happen after the station is built. Out on the bridge, sparks bounce off the glass station as the welders kick it into high gear. This weekend's deadline is approaching fast. The crew works late into the night. Until finally, after more than 2 days of heroic engineering, the last weld is made. And once again, the trains start coming through the station. The impossible feat of building a bridge by lowering 2 towers has been a tremendous success. But this crew know they'll only get 1 day off, because in less than 10 months, millions of World Cup football fans must travel through this station. So Tuesday morning, they start planning the tip-over of the second office tower. It is a race to the finish. Glass roof, tunnels, tracks, office towers, and even the landscaping. If they are successful, this mega train station will claim its rightful throne as Europe's largest, transforming modern Berlin into the center of Europe.